Then the next one is linear functions. So linear function is defined with y equal to ex plus b. Okay, some other textbook might write down as not as ax plus b, but y is equal as mx plus b. This one okay? Or some other textbook also writing down as y y equal to mx plus c. So whichever, I mean you can write down as ax plus b, mx plus b, or mx plus c. All of these three is just a different way to represent linear functions. So for examples, let's see, we have linear function as y equal to 2x minus 2. Okay, so let's see, we have element in the domain as minus 1, 0, 1, and 2. So who will be the pair in the range or output area? So we can calculate for for y equal to, oops, hold on, yeah, let me just mention to you that here fx is just equal to y equal to 2x minus 2. So this one I forgot to mention to you that y itself is just equal to fx, so we can put them as y, also we can put them as fx. It's just the same things. Okay, we put there as y because normally ordered pair we put as x y like this. Rarely we put x fx, but both is representing the same. So either you put as y or you put as fx, is just the same. So now coming back to our discussions here, so we would like to find out who is the pair for minus 1, 0, 1, and 2 in the range area. So we have for f minus 1, what will be y? That will be 2 times minus 1 minus 2. So we have 2 times minus 1 is minus 2, and then minus 2 we have minus 4 in here. And then for f0 we have 2 times 0 minus 2, so we have 0 minus 2, we have minus 2 in here. For f1 we have 2, 1, minus 2, then we have 2 minus 2, we have 0. And then for f2, then we have 2 times 2 minus 2, we have 4 minus 2 equal to 2. Now we get the pair now for each of the input in the domain area, which minus 1 will be with minus 4, 0 will be with minus 2, 1 will be with 0, and 2 will be with 2. Okay, so let me just put the line. 1 with minus 4, 2 with minus, 0 with minus 2, and then 1 with 0, and then 2 with 0. So what do you think this one? Quickly you can just say that this is a bijective function because it is surjective and at the same time it is one-to-one. Surjective because all the elements in the range have pair in the domain, there is no left behind, and also each of them they are pair exactly 1-to-1. Minus 4 pair with minus 1 only, minus 2 pair with 0 only, 0 with 1 only, 2 with 2 only. So they are 1-to-1 at the same time onto, so we call them as bijective. So that's linear functions. And also for your information, or you already know from before, linear functions, if you put in the Cartesian x and y, so if you graph or if you draw them in the Cartesian product x and y, linear functions will have a straight line like this. So y equal to x plus b. So whenever you draw or you try to map linear functions into a Cartesian product, they should form a straight line. That is why we call them a linear. Okay, so another textbook, instead of saying linear function, they will call as a straight line functions. Okay, so that the so that the type 3 is in the special function. So the first one earlier is a constant and then identity, and the third one is linear function.